This is the first video of the Chapter 5 test review. Starting out here with number 1, all it asks for is us to find what the compound interest formula would be. Well, I know that formula is A equals P 1 plus R over N raised to the N T power. Okay? So that'll be given to you on the test. You'll have it either written on the test or on the formula sheet. And all I have to do is plug my information into there. We don't know A. We do know P. It's 11,000. 1 is always that 1 plus this rate. We're in percent land right here. We have to move over to decimal. So it would be 2, and we move that decimal 2 places, meaning we have 0.02 or 0.02. Our N is quarterly, which means 4. And then we raise it to the NT power. Well, we know N is 4 times T. They didn't give us T, so we just leave it as a T. Number 2, this is actually asking us a question about the problem. It says, if you deposit this much with this rate and it's compounded semi-annually, how much money will be there in 5 years? So we don't know A, P, R, N, T. Our P is 700. Our rate, we move that decimal 2 places, meaning it's 0.027. Our N is semi-annually, which means 2. And our T is 5. So we plug all that into our calculator to find A, and we can plug it in right to the home screen. Okay? So we have 700. 1 plus alpha y equals enter. Our rate is 0.027. Our N is 2. Close those parentheses off. We raise it to the N times T power, which is 2 times 5. Press enter and it tells us about $800.45. Remember, with dollars and cents, here's our dollars and these are our cents. So with money, we round to that hundredths place. If you just put 800, it's probably going to be fine. But know that you round to that hundredths place. So our answer is $800.45. Number 3, it's got a lot of the same numbers, and this was a little bit tricky today, so I'll make sure it doesn't happen again. This is a lot of the same numbers. In fact, it's all the same numbers except for they didn't tell us what T equals, but they told us that A equals 1,200. So again, we're in our calculator, but now we have to graph it because we're trying to find an intersection between these two formulas. We have 700. Our rate and our N are still the same thing. And now we raise it to the N times T power. And we know N, but this time we actually didn't give T. So a lot of people were plugging 5 in here because the last problem said 5 years, but this time we didn't have T, so we used X or times X, just so that it looks like the formula. We want to know when this intersects the line 1,200. So we zoom 6 to start. After that, you've got to do zoom 0, which is zoom fit. There, our calculator tried to fit both those lines on there, and it did, but we want the intersection, so we have to zoom out. Now I can see that intersection, so I can calculate it. Second trace, that gives me that calculate feature. Number 5 is our intersection. Press enter 3 times. It will take about 20.1 years or just 20 years to get to $1,200. Okay, so either 20 or 20.1, something like that, years. Remember, it's multiple choice on the actual test. We're back to a problem where we were given T, and what it wants to know is what's the final population going to be. So we need to know A. What we have is that P equals 45,000. That's how many people are in this big town or in this big city. Our R is decreasing negative 0.123, because I take this decimal and I move it 2 places. Okay, that's kind of an odd one, but it's still just move it 2 places. Okay, our n, they didn't tell it to us, but we always have n even if they don't tell us. N is 1. And again, our t, I ran out of room, but our t is 5 years. So we're hopping over into the calculator. We're back at the home screen because this one we're just finding a. And when we're finding a, we can just calculate it. 45,000. 1 plus alpha y equals enter. Our rate is negative 0.123. Okay? Move that decimal 2 places to the left. Our n was not given, but it's 1. That's very common on these population problems. And we're raising it to the n times t power, which is 1 times 5. When we press enter, it tells us in about 5 years, our population has dropped all the way down to this number. Now, we're not going to have decimal amounts of people. So we take that 8 and we bump up that next number, 23,346 people. Number 5, our population's increasing, so this is a positive rate this time. So it's going to be 0.07. That decimal was here. We moved it 2 places. And now we're actually finding when does it equal 9,000. So A equals 9,000 this time. They gave it to us. They gave us a P, starting amount, a rate. They didn't give us N, but that means N equals 1. And this time they wanted to know how many years. They're asking how many years. So T is what we don't know. When we don't know T, we're looking to graph it and find an intersection. So our population was 5,700. 1 plus alpha y equals enter. Our rate was 0.07. Our n was 1. And we're raising it to the 1 times t power. And we don't have t, so we just use x. We want to know when did that population equal 9,000. So we're looking for an intersection between that equation and 9,000. Start with zoom 6 again. Okay, anytime you change something with the formulas, if you type it in wrong or anything, start back with zoom 6. Okay, after that, we want to zoom 0. Then it's going to try to fit both those on the line or on the graph, both those lines on the graph. Oh, and this time it did. We can already see our intersection. So second trace, or that calculate right there, number 5, enter, enter, enter. That tells us that in about 6.8, because that'll round up to 6.8 or 7, 6.8 or 7 years, we're going to have that population we want. This is 6.8 or maybe 7 years, depending on how the multiple choice is worded, or how the choices are worded.